Hello, we're standing in a quarry that is within the Whiteshell Provincial Park. It is a quarry actually owned and operated by Parks Branch. This is a stone that had been removed and crushed to various sizes so that the parks people could use it in various places within the park. In the distance you can actually see the rock face. There's appears to be two general different colors of stone there. One stone on the left tends to be pinkish in colors, probably more of a granite. And then the stone on the far right, it's more grayish in color. And it was probably a granodiorite, quartz diorite in composition. There's some huge fracture surfaces that are buff in color within the quarry. This little pond in the quarry probably served and does serve right now as a bit of a sump. It gives a place where melting rain and snow can go into and to keep the quarry floor relatively dry. That way you can operate trucks without having problems with them getting stuck. So this is something that happens in a lot of quarry sites. It's a way of dealing with surface water. And ironically, further up, bulrushes have developed in the floor of the quarry into the sump. So they're quite content. We see quite a bit of vegetation having grown into the bottom of the quarry. And this all happened since the quarry operations pretty well came to an end. I'm standing in front of the fault surface inside this quarry. This would have been a fault surface that was here millions of years ago below surface. That would have been up above me, the top of the ground level at this locality. This fault surface, if I take a measurement and see what the general orientation it has, this would be fairly representative of its strike direction. So if I measure the strike at this point, it is about 135. If I hold my hammer generally horizontal, it gives you a plane of reference. From the tip of the handle down to where it meets the rock surface, this surface is considered to be the dip of this fault surface. This angle in through here is 66 degrees. As measured by my Brunton compass. So I know that this rock surface strikes, I believe I had said 135, and it would then have a 66 degree dip. The next rock surface to let's say following my hammer is parallel to this one. It doesn't appear to be quite as rusted. This one was probably a wall that had a lot of groundwater coming right from surface. So any vegetation that was up above that had organic material on it would have been carried along this fault surface, and that has actually altered that surface and made changes to it. So if we look on the gray rock surface to the north of us, there is a number of faults and fractures in there, and there are color changes that you can see. A lot of that would be where the groundwater has come from up above and dropped downward. This is exactly the same kind of stone that was quarried by Canatel at their quarry. Why is it broken as badly? It's probably due to the blasting. The blasting has really destroyed or damaged the competency of this particular stone. So it is no longer a tight stone like it was in the Canatel quarry. At that quarry you could get large blocks out that would be several meters in size. Here there is nothing that can be extracted that would be of any economic use. You'd have to maybe go in and remove all of this material by selectively drilling and selectively blasting to find good material. To my far left is the color change to the more granitic rock, And so what we can do is have a closer look at that to see what kind of rock it might be, but I'm certainly going to avoid that rock face. If you look there, you can see the separation between the fracture wall surface and the large blocks. And those large blocks on the very top are providing weight that is going to eventually cause the bottom of that section of rock to collapse. Here we have the basic types of rock that are found in this quarry. As mentioned earlier, the rocks on our left or on the south side of the quarry tend to be the pinkish colored rock that you see in through here. It is an equigranular kind of stone. This would be a good granite for all intents and purposes. It's got the small pink feldspars, small quartzes quartz crystals in there, as well as a few little small mafic crystals, probably hornblende or pyroxene. Now, in contrast to that, on the north side of the quarry, or my right, that when we approach the quarry, is this gray colored stone. This is the one that was quarried by Canatel granite. So it's got these large phenocrysts of feldspar, either microcline or orthoclase, I'm not quite sure which, and then a fairly smaller ground mass of mafic minerals, probably biotite and hornblende or pyroxene, and quartz. But the large crystals, these large phenocrysts, are again feldspar, either orthoclase or microcline. So the two rocks are similar. We call them a granite in the general sense, but this is really a true granite. This would be more of a granite diorite in composition as opposed to what would be a true granite. Now, sometimes in the granite you will find larger phenocrysts of other composition. And on this rock, you can see there's actually some large tourmaline crystals that are in there, or possibly the pyroxene, but I can't quite be sure. You have to see them on end to be able to determine whether they're truly tourmaline. But this, again, is a quite common, when the rock becomes more what we would call pegmatitic, instead of having it as equigranular, like you see on this rock. This is also fairly fine-grained or fine to medium-grained granite, equigranular. This portion is actually a pegmatite, which would have been cooling in the Pluton or batholith much slower, and you would have larger crystal growth. So you have much larger areas of feldspar, also with these larger mafic minerals scattered through the ground mass.